Hello, this is Faith Juma, a member of multidisciplinary group presenting to you a solution of a problem in transportation sector. The problem was identified by us as a group, and it majorly deals with it's all about accidents. So in the current world, everybody always experience an accident in one way or another. So we as a group decided to come up with a solution to do away with the cases and the causes of road accidents. So after we had done some interviews, we found out that the major causes of road accidents were carelessness in driving and traffic jams. The carelessness in driving mostly were caused through the drunkenness of the drivers. Some of them were driving when they are too tired until they get asleep while driving. So the kind of those were the causes of road accidents. So our solution to this problem was introduction or the implementation of Vehicular ad hoc network. It is abbreviated as the VANETs. It's abbreviated as the VANETs. Here the V stands for vehicular, A stands for ad hocs, then NETS networks. So that one is the abbreviation. So to a person who is hearing this term for the first time, VANET refers to a network created in an ad hoc manner where different moving vehicles and other connecting devices come in contact over a wireless medium and exchange useful information to one another. So from the definition, the major function of the VANET will be to provide safety to the vehicles and to anyone that involved in the traffic through the sending of important information to everyone. So the information can be sent through the VANETs. So presented here is the VANET system domain. The VANET system has 3 domains which collaborate and work together. The first domain is the mobile domain. Here. I don't know whether you can see it or whether my pointer works. Here, mobile domain is the one of the domain. It also has a vehicle domain and a mobile device domain. So vehicle domain consists of all kind of vehicles that are required or that are involved in the road that always take part in transportation, whether cars, lorries or buses. And for the mobile device domain entails every kind of portable device, be it smartphones, anything, or any device or personal navigation device that are used are all part of the mobile device. Then for the generic domain, we also have internet infrastructure domain and private infrastructure domain. We also have infrastructure domain with the roadside infrastructure domain and central infrastructure domain. So the roadside infrastructure domain majorly deals with the collection of information through the sensors along the roads, and they transmit them to the required destination. So here the roadside infrastructure domain entails roadside units, which can be traffic lights. And for the central infrastructure domain, There are traffic management systems and and vehicle management systems. So presented here is also the domains presented in a better way. We have the infrastructure domain, mobile domain, and generic domain. So the way they work, here we have mobile domain, we have vehicle and phone, we have traffic light here and management center as the infrastructure domain, and we also have generic domain here. So infrastructure domain. So how the three domain work together is as follows. For the mobile domain exchanges information and communication to the infrastructure domain here. Then the infrastructure domain processes the information that was sent to it by the mobile domain, and after processing plus modulation, it also transfers the information to the generic domain, and vice versa. The generic domain also transfers it back to the infrastructure, then infrastructure also sends it back to the mobile domain, and that's how the three domain of VANET system coordinates. So we have there is a communication architecture, because VANET majorly deals with the communication. So there is a communication architecture within the VANET system. So the types of communication involved in the VANET system, we have the in-vehicle communication. In-vehicle communication represents an inner system data or performance of the vehicle and determines factors such as driver exhaustion or drowsiness. Then the determination of such factors and their extent is crucial for public safety as well as driver safety. So here the representation of in-vehicle communication in this aspect, let's say this for this car here, or maybe this, let's use this, but let's use the red one here. So in case the driver within this red car is asleep or is drunkard and he is driving, so that means that there's some danger inside. So the system detects the condition of the driver within this car. Then if the driver is sleeping or any other thing, it sends warnings to other vehicles. Maybe the message may read that they should not get close to this car because it is not going to be safe for them. That is the in-vehicular communication. Another one is the V2V. That is the vehicle-to-vehicle communication. In the vehicle-to-vehicle communication, the data is exchanged between different vehicles so as to assist the driver by informing them about warnings and other crucial information to one another. So here, in case of, for example, this blue car is likely to collide with the red car. So in case of VANETs, in case of collision, the blue car will send messages to all the nearby vehicles so that they should not get close to it because of the crash or the clash that has occurred, or it is likely to get into. So the vehicles can then make decisions to get to some other better roads or go back, or any other thing that can help them not to be involved in the road accidents too. So that is the V2V communication. So here This one also represents the V2V communication. The vehicle here can send messages and receive messages. It can send messages in a view of 360 degrees and to every vehicle that is around it, I mean by 300 meters. So in case he wants to overtake, then it will have gotten some information from a nearby car that also was overtaking, not to cause accident or any misunderstanding. Or so the vehicle here will also get the information about this vehicle. Let's assume this vehicle wants to overtake this, so this vehicle will also get to know the speed of this vehicle. Those information will be sent to this vehicle here, so that even if it will be overtaking, it should know the speed at which it should be using. That one is not this one is another form of V2V communication. Another one by the way, here we have this vehicle communicating directly to this communicating to this, and this also communicating to this. That one is a V2V communication. So another type of communication, you have V2I. V2I, that means vehicle to road infrastructure communication. So the road infrastructure in this sense may be anything that is beneath or besides the road, or even within the road. So maybe there are some breakage within the road, or some flood. So for that, the vehicles will get communication from the roadside units, of which and the roadside units in this case is this one. It will send the information to every vehicle that is nearby it. So that is the one which is known as to V2I communication. Then the last one is vehicle to broadband. Vehicle to broadband cloud, V2B communication. So it allows communication of vehicles over broadband connection such as 3G or 4G, and it enables the driver's assistance and vehicle tracking, as the broadband cloud may contain more of traffic information and other data. So those ones are the 4 types of V2V, or not V2V, the communication architecture that is required in the VANET architecture. Now after that, we have the VANET system nodes. There are 3 types of nodes that are required for the VANET systems. The first one, you have the terminal node, relay node, and mobile node. In this structure, the mobile node, the mobile, so they represent the mobile node. The relay node are represented by this blue, like I don't know whether they are batteries or any other thing that you can see them to be. So this one is a relay node, this, and this is a relay node. Then the terminal node is this one, this one, this one. Then these lines, the blue line, the red line, and green line at the mobile node route. So from there, we can determine that the mobile node, because there is a route for a mobile, meaning there must be something to do with transportation. So here mobile node works by transporting data through the mobile node route. Its main work is to it's mainly responsible for the physical transportation of data between the terminal node and the relay node. So it majorly transports data between the terminal nodes from here to here. There is a mobile node. It will transport data through the mobile node routes to the terminals. So that is the function of the mobile node in this case. Another node is the relay node here. If you observe it keenly, you will get to find that it is majorly placed within, between the intersection lines of the mobile node routes. So it is placed in the intersection to help the mobile node bypass data along the network. So it just supports the mobile node to bypass data. Then mobile node route allows mobile nodes to transmit data to the terminals. Then the terminals receive the information, the data that are being transported by the mobile node. And then here we have the users who are intending to use the information that are transported. So that's the reason why the users are mostly in the terminal node. Okay, so lastly we have the VDTN routing protocol. So this one is the routing protocol that we proposed to implement in our project, in the VANET, the Vehicular ad hoc network system that we are supposed to implement. We are supposing to implement this VDTN. So the VDTN in full, it's vehicular delay transport network. So it also has terminal nodes, vehicular node, intermediate bundle in buffer, then the bundle transferred. The terminal nodes are here. They receive they receive the information now. The terminal node in this case the terminal node here, they are like buildings, these ones, so they receive the information that are being transported, and the information in this case are in bundles form, these ones. So this one represents the information transported. So in this case, some goes to the terminal and some is provided to the vehicular node. Yes, so this one is the end of our presentation, and thank you for your time and have a great day. Thanks.